Well, students, today we're going to graph rational functions, rational equations. Again, think of the root word ratio. It's a type of a fraction. And these are very strange looking graphs. I find them kind of interesting. I hope you will enjoy them too. But on your notes, number 1, we're going to do that right in the calculator right now. So if you'd please go to the y equals menu. And there is a particular fraction template I want you to use. And if you'll go to, let's see, what is it? It's alpha y equals. Let's go there first. We're in the y equals menu to begin with, and we go alpha y equals. Now select number 1, n over d, which stands for numerator over denominator. And from your notes, you're going to put in the number 3, which is in the numerator. Then arrow down and just type in the x plus 1. Now the last thing you need to do here is to right arrow to get out from under that fraction symbol. And then we're going to put a plus 2. Now what you're going to see is a shift to the left 1 unit and up 2. And again, you're noticing by now that this type of thing is always the opposite sign of what you'd expect. So we're going to go left 1 and up 2. And let's hit zoom 6 as usual. Okay, now these rational functions will always have 2 branches. If it's positive, it's coming in this way. If we're negative, it would be coming down that way. And so you've got 2 branches. What I would like you to see, or at least to imagine in your head, is that there is an imaginary line that splits it here and here. Now, this is called the horizontal asymptote. And it's a weird word, but that's what it's called. And the vertical line is, as you might guess, called the vertical asymptote. Now, again, it may not be obvious to you, but this is going through where y is equal to 2, and that was the 2 at the end of our equation. And this is coming down through negative 2 on the x-axis, which was, if you plug that into the denominator, would have created negative 2 plus 2, which would have been 0, making it undefined. And on that note, I'd like us to go look at the table. And I think you can see that a little more clearly. So we're going to go second table. Well, okay, I've got my table is messed up, so this is a good chance to learn how to do it. Let's go back to second table set above window, and we're going to start at 0, and then that should do the trick for us. Now let's see, we're going to go second table. All right, so far so good. It gives us fractional forms for the answers, but let's go look up here. All right, look what happened at negative 1. We've got an error message. And that actually, oh yeah, okay, I was thinking we had a different number here. Yes, the vertical asymptote went through negative 1, not negative 2, as I said earlier. And that's why you have an error message there, because it's undefined at that point. Okie dokie. Now let's go look at your notes. And again, this is the same problem. First time through, I'm just going to show you the answers so that we can figure things out here. Now you can see the 2 branches like so. You can see the horizontal asymptote, the vertical asymptote. And so the vertical asymptote is x equals negative 1. The horizontal asymptote is y equals 2. And when you're graphing by hand, you want to indicate these lines. Now, the domain is all values of x forever to the right, forever to the left, except right there at -1. So we can say it's all real numbers except -1. And the up and down values, the range at every ordered pair here, it's only where y is equal to 2 that it's undefined. And so the range is all real numbers except 2. So now let's go look at number 2 on your notes. The first thing that I would like you to be able to do is to decide where is this thing going to be undefined, because you may remember that anything divided by a 0 is undefined. So what number, if I plugged it in here, would create a 0? And I think you can see that it's +2, because 2 minus 2 would be 0. So that means at +2, we're going to have a vertical asymptote. And so if you would go ahead and sketch that in, and you can put VA for vertical asymptote. The -2 means there's going to be a horizontal asymptote at -2 passing through the y-axis, and we'll call that HA, horizontal asymptote. And now it's time to draw in our branches. And because it's positive, you're always going to have a branch that comes in here and swoops down here, but it actually never touches these asymptotes. And similarly, you're going to have one here likewise. Now, at this point, I'm not going to ask you to plot points simply because we have the calculator, but I'd like you to see what the key indicated the answer should be. And I didn't do too bad in sketching that out. And vertical asymptote at +2 on the x-axis, horizontal asymptote, y is equal to -2. The domain will be all the x values except when you get right there, and that's at 2. And similarly, the y values, the up and down, they'll all be there except when you get, let's see, where am I? Yes, right here at -2 on the y-axis. Alrighty, let's continue on. Whoops, I'm showing you the answers. I don't want to do that yet. Okay, now notice the negative, so the branches are going to be different. But our vertical asymptote, again, you say, well, what would make this denominator 0? Because that's what we need to exclude. Well, we have to exclude where x is +2. So we're going to do that, and that's our vertical asymptote. We also need to exclude where y is +2. That's the horizontal asymptote. And we can go ahead and decide the domain and the range. Well, let's go ahead and we'll graph it first. Because it's negative, you're going to have a branch up in quadrant 2 and a branch up in quadrant 4. And let's check the answers. Alrighty. So again, the domain will be all real numbers except when you get to +2, and then it splits. And similarly, the range, you've got all real numbers except when y is +2, and then the thing splits. And it splits because it's undefined at that point. And let's see what else we got here. Let's see, I think I'm going to pass on number 4. Yeah, let's do 5, because it's even though it's a simpler thing, it may look a little bit strange to you. All right, well, what would make this fraction undefined? Well, how about if x was 0? So where is x 0? Well, it's right here, where the y-axis then becomes the vertical asymptote. The horizontal asymptote is at -1. And it's positive, so that means you'll have a branch in quadrant 3, a branch in quadrant 1. And let's take a look at it. Like so. The domain is all real numbers except when you get to 0, and then that's when the thing splits off. Similarly, the range, it's all the y values forever, up positive infinity, negative infinity, except, let's see, where am I? Yes, when we get to -1. And let's see, I'm going to skip 6, I'm going to skip 7, and I think I'll skip 8. That should be sufficient for your note taking, and we'll stop it right there.